Hello, I'm Dan Bowles. This video is the first in a series to teach the principles of our physical existence as presented in my book, Are We Just Bubbles? An Alternate View of Existence. A good place to start is at the beginning. So I will begin with the physical existence of space. Now, even though we can't see anything in the empty space between us here on this earth, we know that it's not really empty. We breathe the air that fills this space. We can feel the force and movement of air in the wind. The air physically exists even though we can't see it. In the same way, universe space exists and is a physical part of the universe even though we can't see it. In the vacuum interstellar space in our galaxy and vast regions of intergalactic space within our universe, there is a real and physical space existing even though we can't see it. This idea might give some of you a touch of heartburn because we have always thought that space was emptiness and didn't consist of anything. But this philosophy comes from the primitive notion that it doesn't exist physically if we can't detect its existence with our senses. These types of things were thought to be spirits before we became enlightened. But like the invisible air, there are indications that empty space is physical because it interacts predictably with other physical things that we can see, and that it is not a spirit acting with its own will. We know that space exists because electromagnetic energy, gravitational fields, and the like exist in it. We know that there is a connection between space and time as predicted by Einstein. An inertial force and gravity can affect objects in empty space. Electric and magnetic forces are transmitted through space between objects. These actions in empty space are indication that space is physical, and these forces are not the actions of some invisible spirit. So if it physically exists, but we can't see it, what's it made of? Now this answer is probably going to shock you. But vacuum space is made of invisible space bubbles. As a matter of fact, everything physical in the universe is made of space bubbles too. Let that sink in for a minute. Everything in our physical reality consists of invisible space bubbles. You could think of these bubbles as a foam, all of empty space. The empty space between stars and galaxies, the empty space between the atoms, the space inside of a solid between the electrons in the atoms, and even in between the components of an electron and the tiniest subatomic particles in the nucleus of an atom. These spaces are all composed of vacuum space bubbles. The solid subatomic particles of an atom, the ones that we can detect, are composed of compacted space bubbles. These compacted yet still expanding bubbles consist of various combinations and arrangements of space bubbles that make up the various forms of matter. The fact that they are compacted and denser than the vacuum space bubbles is what makes them visible to us, as they have properties of mass. Our universe space is finite. It has bounds. It doesn't go on forever. At the space boundary of our universe is an infinite void, an abyss where absolutely nothing within our physical capabilities to detect exists. There is no time, no energy, or forces of any kind that we could detect outside of our universe boundary. In the last few decades, the scientists of the world have been on a quest to find the ultimate component of the universe. Leon Lederman called it the God particle. Some have named it the Higgs boson. In order to see if it really exists, scientists of the world, in a multinational effort, have built a $9 billion atom smasher in Switzerland called a Large Hadron Collider. It is the largest machine in the world. It's donut-shaped, it's 16.7 miles in circumference, and it is buried 600 feet deep underground. It is used to accelerate two streams of charged particles going in opposite directions to almost the speed of light, and then smashes them together to see what flies out. Now, according to some scientists, God particles supposedly pop in and out of existence from absolutely nothing. So, it might be a problem to detect their existence from the shards of a collision. It's sort of like smashing a rock with a giant hammer and trying to figure out what it's made of by looking at the dust and shrapnel flying out. According to what I believe and propose in my book, scientists will never see a God particle. This is because what they are looking for is an invisible vacuum space bubble. They do exist and make up everything physical in our universe, but there is nothing in our universe that will allow us to see them directly. We can only anticipate their presence by the actions we see on matter, which is just compacted space bubbles. The point I want to make here is that space as we know it consists of vacuum space bubbles. You might wonder, what are the space bubbles made of? It turns out that each bubble is made of its own unique universe space that it cannot share with its neighbors. Each little bubble is unique and individual and has a creative source within it that is continually making its own new space material and causing the bubble to expand against its neighbors. Where does this new space come from? It comes from a creative source outside of our universe, reality, and it is unknown to us. Something outside of our universe is pouring new universe space into each of the space bubbles. You might want to think this source is from God or a creator. Others and some scientists would rather think that it comes from nothing rather than a creator. But in any case, we can't ever know for sure because it is outside the bounds of our reality. How big are the space bubbles and how can we measure them? In order to answer this question, we will have to examine what it is we are doing when we measure something. The first thing we do is to assume that the object we are going to measure is finite, that is, has a beginning and an end, and that it is constant, that is, not changing in length while we're trying to measure it. Then we take another finite and constant object that was set up as a measurement standard, a ruler, and compare that length to the object being measured. The comparison is done in the form of a ratio of the object length to the standard length. So we would take this ruler, put it on the beginning part of the measurement of the book, and we'd go over to the width and look to see what that reading is. It's 6 1/4. So that is 6 1/4 units over above one book width. Our universe space consists of vacuum space bubbles. For reasons to be explained later, these bubbles are all cubes of uniform size. The cubes are three-dimensional, but I have represented them here in a 2D space as squares for illustration simplicity. The bubble cubes have a creative source of new space material within each of them that forcibly expands the bubble against its neighbors. Since the expansive force within is equal and the bubble space material cannot mix, boundaries between the bubbles form into congruent flat sides with no spaces between them. The sides have to be flat because a curved boundary would indicate unequal forces. Since all physical things in the universe are made of space bubbles, all of space and objects with matter are expanding in proportion to the vacuum space expansion. Although vacuum space expansion is not the same rate throughout the universe, its rate in a given region, limited by the equilibrium reached between the bubbles in that region, is the maximum rate of expansion of the bubbles. The space bubbles within a cluster, this would be matter with mass, expand at a slower rate such that the cluster expansion is in proportion to the vacuum space expansion. So even though universe space is expanding everywhere within, we cannot detect it because we are expanding along with it. I have depicted a portion of vacuum space here with two objects of matter that are separated by a distance in space. The objects are formed by a cluster of compacted yet still expanding space bubbles whose mass is proportional to the density of the cluster to that of the vacuum space bubbles, which have a density of 1. Also have depicted a ruler here which is composed of space bubbles in the form of vacuum space and matter and will be used to make a measurement in space to determine a distance between the objects. For demonstration purposes, I have shown a distance of a line of vacuum space bubbles that is equivalent to the line distance on the ruler. Since all matter in space is expanding in proportion to the vacuum space bubbles, we can use the quantity of bubbles to illustrate the distance in space. We can take a ruler and measure the distance between the two objects in space. They measure 3 1/4 units. Both portions are composed of space bubbles and are considered constant and not changing. So what we're really doing is comparing two portions of universe space against one another. What this means is that the number of space bubbles along a line in the measurement standard and the number of bubbles in a line in the object being measured is not changing while the comparison is being made. Okay, this is fine when we're measuring objects, but what about the space bubbles themselves? Are they growing bigger into the empty void as each space bubble expands? Well, the answer is yes. This is the thing that scientists have overlooked or have not considered in the quest for the God particle. We can take a look at our same two objects and ruler after some expansion and time has passed, and the measurement will be the same. So we could take this new ruler that's expanded along with space and measure here, and it's 3 1/4 just like the other one. The space bubbles that everything in the universe is made of are expanding onto the infinite empty void of non-universe space. We cannot see this because everything we can see, the objects and measuring standards, are expanding along with the space bubbles which they are made of. The number of bubbles between the measured objects remain constant, so the distance appears to be constant to us. In both cases of the measurement illustrations, we are viewing the actions of the universe as though we were outside of it and could see the expansion. Since all the actions of the universe are based upon invisible expansion of the space bubbles into the void, we need to measure the expansion with a ruler that doesn't change with universe expansion. I have devised a ruler to measure that doesn't change with universe expansion. It has units of Frenches, which is the initial size of the universe when it began. So, no matter if it expands or not, we're comparing the current size with the initial size, so we could see a change. So if we measured the first instance that we had, we could see that it was 6 1/2 units of measure between the two objects. Then if we looked at the other condition, after it expanded and time had passed, we see that now it's 13 1/2 units of measure. So what that means is, even though the universe and everything in it is expanding, we cannot see that. Or we can only see it in our minds and determine that it is so by its actions upon the things we can see, matter and gravity and all of that. I will list what we have discovered in this session. Everything in our universe consists of invisible expanding space bubbles. Compacted groups of space bubbles become visible as matter with properties of mass. Measurements that we make are just a comparative ratio of two portions of space, one being a measurement standard that is considered to be constant. The ratio is really a comparison of the number of space bubbles in a line between 2 points in universe space. Each space bubble is unique and cannot share space with any other bubble. The boundaries of each bubble are made of its own unique material, and it has a creative source within it that makes it expand at the boundaries of its neighbors. There are no voids of non-universe space between the bubbles. Therefore, they are not round. They are flat-sided polyhedrons whose sides terminate on each other. The vacuum space bubbles and compacted groups of bubbles are invisibly expanding from within into the infinite void of non-universe space. The expansion and interaction between the bubbles causes all of the properties of the universe: time, energy, gravity, inertia, and the like. This type of expansion is strictly invisible to us. The bubbles can only expand. There is nothing in the universe that can uncreate space or force it back to where it came. The expanding universe that we can see is not the same as this invisible expansion. Instead, it's caused by actual movement of bodies of matter within the vacuum space bubbles. The apparent compression of space, as we might observe in a black hole, is the result of that space expansion slowing down while we and our surrounding space continue to expand at an ever faster rate. This concludes session 1.